So let's go now. This is sets, and in this class we'll concentrate to pay particular attention to simplifying sets and also solving and shading. All right. Now, from the previous class, we already established some facts, which I want us to review again because it will be very important for today's class. So, what are the laws of sets? You need to know this, and it might seem that easy, but if you don't know, you will struggle. All right. The first one that I want to know, the general. Okay, for me, I arrange them like this. I put rules and then laws. Okay, so that we just know what is what. So I'm gonna start with what we call the rules of sets. Please ask in case you get a question, as I and I hope you have got a book and you're writing down. The first rule of a set that I want you to know is that when you have got any set, and I mean literally any, okay, any set, intersection itself, the answer will just be itself. A intersection A, all right. So A intersection A is an why am I writing empty set when I said something else? So A intersection A is just going to be the set A. That is the same thing. A union A is the same set A. And then the second one I want you to know is when you get a set and then you deal with an empty set. Let's say A intersection an empty set. What are you gonna have? Remember from the previous class, I told you that every time two sets are intersecting, you always get a smaller set. So an empty set barely has anything. A set A at least has got something in there. Therefore, a set A, okay, from my end, the network is breaking. Are you clearly getting me? Alright, great, thank you. So A intersection an empty set is an empty set. I want you to know that. I'm going to write it down. And then A union an empty set is a set A. So the principle here is that for intersection, get smaller set. And then for union, get a bigger set. It's a very simple principle to be able to apply. Number three, what I want you to know is with a union set. So if I get a set A, I intersect with a union. Remember union, I can either use E or I can use U. It all means union. So don't get confused in case in the exam they either use E or they use U. So a set, intersection, a universal set. Universal set is the biggest set. So from the rule that I've talked about, if you get a set, intersection, universal set, the smaller set in this case is going to be that same set. So the answer will just be that same set. Remember, that's the rule we've said. And then any set, union, the universal set. Now union, you get a bigger set, and the universal set is a bigger set, so it will be actually the universal set. Okay, the fourth one is when you're dealing with a complement. So any set, intersection, its complement. Now you don't have anything common between a set and outside the set. In other words, you cannot find an element inside you and outside you. The other time I told you that you cannot be positive and negative. You can't be saying My obukopo bwankola in and you want to go and pass an exam. Where? You post, you get a meme on from somewhere, you post on your status with obukopo bwankola in. No, you can't pass like that. For me, you can't be my friend. You get a meme from somewhere ati awo twalipona kale ifwe leke ntulaleko, but you are from jobbing, you are from studying, twalipona kale. How do you post such a thing? No, you can't do that. Stop. All right. So a set intersection and empty set is an, I mean, a set intersection is complement is an empty set. There's nothing common. So please stop using some words. Stop posting some memes. You can post many things, but don't post some memes, especially those that have to do with your future and such. But if you get a set, union a complement. Now, union means that you are combining. You are combining what is outside with what is inside. And that will give you the universal set. Okay? The other one that I want you to know is when you have got a complement with another complement, the answer is just those two complements will cancel out. As simple as that. And then I want you to also know what we call the difference law. Okay? So this one is A minus B. A minus B means that you are looking for elements that are in A but should not be in B. So A minus B is the same as A intersection B complement. This is known as the difference law. Okay. I hope, are we okay with the rules of sets? Are we good? Let me just see if we are okay. Excellent. Now let's talk about the laws. Okay. For me, I just decided to split them like this. So the laws, the first one is the law of commutativity or the commutative law. Uh, I've seen a hand. Yes, please. Is that a question? Hmm. Okay, it's that one. You just need to know it like that. It's just like that. So if I've got x minus y, it means x intersection y complement. M minus n means m intersection n complement. Is that okay? Great. So the commutative law just tells you it's like plus or times. If I've got A intersection B, it's the same as B intersection A. Same if I've got A union B, it's the same as B union A. That is the law of commutativity. The second one is known as the De Morgan's law. De Morgan's law. The De Morgan's, if you have got A intersection B in brackets with a complement, you distribute this complement to the A and B in the brackets, you end up with A complement. The sign will change. If it was intersection, it becomes union. So if it was A union B with a complement, when you distribute a complement, the sign will change on the middle and it becomes like that. I hope that makes sense. All right. So that is the law. In case your mic is on, just make sure that you switch it off, okay? And then you can be able to ask in case you get a question at any particular time. The third one is the associative law. Now the associative law is like if you if you have 1 plus 2 plus 3, it's the same as you first adding 1 plus 2 and then you add the 3. That's the associative law. And it is true for an intersection and a union of a set. So if I've got A intersection B intersection C is gonna be the same as A intersection B intersection C. And that's the same if I've got union. Okay. A union B union C is the same as B union C. Oh, let me start with the okay. It's gonna be the same as A union B union C. And then the last one is known as the distributive law. So for the distributive, again, it's basically the way you know if you have got x times, let's say, a plus b, is gonna become x a plus xb. So if I've got a intersection b in, let me use a different sign here. Let me use a union. Of course, it's true if you have got even an intersection. You are going to distribute the A intersect, it will go with a B, so that will be A intersection B. And then you get the sign on the middle, that's a union. And then you get the A intersect, you distribute with a C, so that will be A intersection C. This is gonna be true in case I had swapped. Let's say if I had A union B intersection C, all you get is A union, okay, which is here. You distribute with a B, so that is gonna be A union B. Get the intersect on the middle here, and then get the A union, distribute to the C, that is gonna be A union C. Does that make sense, guys? Is that okay? So it means that, okay, let me just give some examples. Now that we've talked about everything like this, let's do examples. Okay. So for some example, I'm going to ask us to simplify and shade. So simplify and shade. The first one we are going to have is A complement intersection B union A complement with another complement there. Okay. So how are we going to work it out? We are going to get it here. A complement intersection B union A complement with another complement. If they ask you to simplify a set, it means that they don't want you to see don't want to see the same letter two times. Like here you can see we are seeing the letter A two times. So what I'm going to do first is I'm going to distribute this complement. So as you distribute the complement, this will be taken as one thing, this will be taken as one thing, and they're being separated by an intersection. So according to the De Morgan's law, if I distribute the complement, that intersection will change into a union. Okay? So this is going to become A complement, it will carry another complement. The sign changes. And then we're going to have B union A complement with another complement. Remember I said if you have got two complements, they cancel out, so that will just be A union, you have got B union A. According to the associative law, anyway, let me just first go here. I told you that when you are simplifying, when you have got a union, the final answer will always be a bigger set. Okay? Here we have got the set A, and we have got the set B union C, B union A. Union means that you have combined A and B. So let me ask you a question. Between the set A and the set B union A, which one is a bigger set? Which one is a bigger set? Yes, Patson? Very good. Excellent. Okay, I love you. So it is B union A. And I told you that when you get the union of a set two sets, the answer always be the bigger set. So therefore A union B union A, the final answer is just B union A. That's the answer. Okay, because it's a bigger set and we are taking union. And according to the, okay, when you have got two sets, right? You have got a set A and you have got a set B union A. You have got a union between them, isn't it? You have got a union between them. So for you to know what is going to be the final answer, you need to know between these two sets which one is a bigger set. In other words, which one is going to be inside which one. So the set A is actually inside the set B union A. All right? So because I'm taking union, union means you get a bigger set. So B union A is a bigger set. So A union B union A, the answer is going to be B union A because it's a bigger set. But if it was an intersection there, we would have gotten the set A because the set A is actually smaller than B union A. And when you are doing intersection, you get a smaller set. Does that make sense, babe? Is that okay? Hey, I was sure. Yalimba, che. All right, where are you confused? Okay, but now if I draw this, okay, it's good. It's actually very good to know how best you learn, and I like visual learning rather than just talking. All right, so we're gonna have this one here and this one here. So this is a set A, this is a set B. Again, this is a set A, this is a set B. So here I'm going to shade B union A. B union A means everything in B and everything in A. So that's a set. Is that okay? And then the set A is just this one. So can you see that the set A is actually part of the set B union A? Yes. So when you're taking union means you're combining the set A and the set B union A. So the answer will just be a B union A. But if it was intersection, intersection would have been looking for what is common. So would have gotten a smaller set, so we could have gotten A. Is that okay? Yeah. So according to the commutative law, B union A is the same as A union B. So if you write any one of this, it's okay. So I've simplified the set and then remember it's simplify and shade. But I've actually even already shaded. So now the shading of this set is gonna be, since we already know the final answer is only A union B, so meaning that after you shade, the shading is going to be this. Does that make sense? Great, alright. So this is A complement intersection B union A complement complement. Alright, let me give you another example. Okay, great. Okay, now let's keep our microphones off for now. So, simplify and shade. And for this one, let's have A union B complement. Let's say we have got intersection A minus B. Okay. And then we have got a complement there. And then we are going to shade. I'm going to give you the set to shade in. Okay. For this one, I'll not give the set because the one I wanted to give is unless when you have got three things. Okay, so this is our our question, and that's the one that we want to be able to work out. Let me put a complement, another complement here. So the way we are going to work out this one, we are going to get A union B complement intersection A minus B complement complement. First, distribute the complement that is from the outside. So we're going to have A union B complement complement. Remember the sign on the middle change to a union. And then we have got A minus B. Okay. That is also going to carry. Mm, there's something that I want to do here. So the way this one is, let me remove this complement from here. Someone is already asking, wants to ask a question. Okay, let me remove this one, this complement from here. Because, okay, there is a complement at that particular time, point, I mean. Okay, you've seen the way I've written it. So I've first distributed the complement to A union B. There was already a complement there, so there are now two complements. And then union, the A minus B are also distributed complement there, so it will be here. Okay, the two complements, remember, they'll cancel out, so that will be A union B. And then we are going to have, please pardon me, I'm going to change this sign here to, I just want you to understand, because the way the question is going, it will be way simple and you might not get the point of me explaining here. So I also change these ones. I want to put a union here. So if I distribute the complement, it will become an intersection. Okay. I hope we are there. So the two complements, remember, they cancelled out. So we had A union B. And then A minus B. What does it mean? It means A intersection B complement. But remember, we already have a complement outside. Alright? And then this is going to give us A union B intersection. I'll distribute that complement on the outside. So we are going to have A complement. The sign, remember, changes. Guys, please, whatever you're doing with your screen, stop. Stop. Okay? Alright. So I'm saying I'm distributing this complement to A complement. To A, it becomes a complement. The sign on the middle changes. And then the B complement is going to carry another complement. So they are now two. So far, are we okay? Is there anyone that's left behind? Where are you left behind? Mm-hmm. Yes. Mm-hmm. Okay. Let me explain this again. You can see this complement, right? We'll distribute it to this side. So they are now going to be two. Is that okay? The A minus B doesn't have any complement. So this same complement that is outside will distribute it to here. That's the one that you can see here. Does that make sense? And then these two complements, see, which are on A union B, when you have got two complements, they cancel themselves. That's why you just have A union B down. Great. And then the A minus B in the brackets means A intersection B complement. The complement which is here is still there. I've not changed it. I just changed from A minus B to A intersection B complement. Does that make sense? So, okay, remember, it's one of the rules. I don't know if you were there when I wrote the rule. If you have got A minus B, it means A intersection B complement. That's the meaning. Yeah. It's okay now? Okay, great. Is there anyone else that has a question? Okay. So now this is going to give us A union B. Yes, Patson? All right, great. So here we have got A complement union. Can you see that B complement complement? What does that going to give us? Yes, excellent. So that will just be AB. All right. I want us to use something. I want us to use one rule, the commutative law. So A union B, when you use the commutative law, what does it become? A union B by the commutative law. Yes, please. Pattern? Very good. It will become B union A. And then intersection. A complement union B. If we use the commutative law, what does it become? Given any thought? Okay, Stanley, I've seen your hand up. You can go on. Very good. B union A complement. Now, I told you of the distributive law when we are going forward. The distributive law can also go backwards. So can you see that we have got B union here and we also have B union here. Okay? So it's like factorization. I'm going to get that B union. What has remained if I get B union is going to be an A. And then we have got this sign on the mid, which is the intersection. And what remains if I get B union here is A complement. So I've used the distributive law, but I've just gone backwards. All right? Because if I want to go back, I'm going to say B union times this A, that will be B union A. And then we get the intersection on the middle. And then the same B union times this A complement, it will be B union A complement, which is the same thing that is on the previous page. So you can utilize these laws that we've been talking about in a forth and backward manner. All right? So from here, this is going to be B union A intersection A complement. Remember what I told you? What is A intersection A complement? Anyone? A intersection A complement? Excellent. Empty set. And what is the set B union an empty set? It's B. Very good. Okay. So this is it. We have simplified the set. That's the final answer. Okay. So therefore, the shading part for this question, this is the set A, this is the set B. So we have shaded there. So if they asked you to shade the set A union B complement union A minus B like that, that's the answer. Does that make sense? Yes, yes, please. Hmm. So it has actually changed, sir. It's here. Are you are you seeing where I'm pointing? Where exactly are you mentioning, sir? Hmm. This one. That's that okay. That's because we don't have any complement to distribute. Remember this, we had two complements, they cancelled themselves. So we didn't distribute any complement to the A and the B, which have been joined by a union. Do you get it? Great. Is there another question? Uh-huh. Exactly. Another question? Okay. Let's now conclude with one last part. Yes, please. Okay. So don't worry. These my beautiful notes I'm writing like this. I'm gonna share with them with you. Alright? I'll send the PDF that I'm using right now. And then I'll also send you the video. Is that okay? You're welcome. Alright, set intervals. So for the set intervals, we already looked at this, but then I want us to solidify. Set intervals, you have got, if you see brackets like this, okay? Please make sure you understand this. You see this, let's say 0, comma 1. This type of brackets, we call them open intervals. On a number line, you are going to write from 0 up to 1. Use open circles. Open circles. You also have brackets like this. Let's say it's 1, comma 4. We call these as closed intervals. So just write from 1 up to 4, but shade 1 and shade 4. Intervals means we are talking about all the numbers from those 2 points. For example, the second one, we're talking about all the numbers from 1 up to 4, including 1 and 4. That's the meaning of a closed interval. An open interval, we're talking about numbers from 0 up to 1, but we're not including 0 and 1. So for example, numbers between 0 and 1, we have got 0.5, 0.0005, 0.000001. In other words, when you're talking about intervals, it's not possible for you to list all the elements that you're talking about. All right, that is a set interval. And then we can also have one like this, 0, comma, let's say 7. We call this one as an open closed. So for open closed, it means that in our set, we are not including 0, but we're including 7 and all the numbers in between. So on a number line, you put it like that. On 7, I've shaded. On 0, I've not shaded. I can also write something like this. Let's say 4, comma 9. This one is known as a closed open. So it means that in my set, we include 4, but we don't include 9. It's like that. So please, as you write set intervals, you always start with a smaller number, then a bigger one. So I can't write 4, comma 1. This is wrong because I'm starting with a bigger number and then writing a smaller one. Another thing is that every time you write infinity, infinity should always go with closed intervals. Okay? Let's say we have got a set A, which is equal to say 2, comma infinity. You can't write infinity like that. That's wrong. So for infinity, you don't really know the number, so you just put it like that. And then let's say B is, let's say the set B is from -3 up to 4, like that. And then say they've told us find, let's say number 1, A intersection B, and then number 2, we have got A complement. Okay, let's start with this. Now, one more I want you to know is when you use curly brackets like this, 2, comma 4. Kelly. So for the Kelly brackets, they represent elements, not a range. Therefore, on a number line, you go on 2 and put a dot. You go on 4, you put a dot. Don't connect them because these are not a range. These are elements. And that's where many people get confused, especially if they find a question where they've combined curly brackets with interval brackets. Okay, so let's answer our question here. Is an example. So for you to be able to work out this question, an easier way to work out sets, okay, when you want sets to be easy for you, make sure that you always use the number lines. I'm seeing a hand already. Yes, please. Mhm. So you've seen this type of bracket here. That's what we call an open interval bracket. You don't shade. And then this type of bracket, we call it a closed. You always shade. All right. So what determines whether you shade or not is the type of bracket. Is that okay? Yeah. So we all right. So we have got our question here to say A is that set and B is that set. Find A intersection B. So the way you find A intersection B is go on a number line. First put the set A. The set A is starting from 2 up to infinity. So 2, you can see 2 is actually closed. Look at the type of bracket I've used. And then we are going to infinity. We don't know where infinity ends. So the way you represent infinity is just put an arrow going forward. Okay. I know maybe the screen is switching off a bit, but I hope you can see what I've written. From 2, just write an arrow going forward. Okay. That is a set A. So for infinity, you don't know where infinity is. So you put an arrow. It's not like a number if they've given you a number. The set B is from -3 up to 4. So -3 is not being included, but 4 is being included, like that. Therefore, the intersection of these two sets will be here where they are meeting. So we'll shade this part. Because most of the questions, the way they'll come is they're going to ask you, find the following sets and show on a number line. So what I'm doing is showing on the number line. So I'm going to say A intersection B. You can see where I've shaded is from 2 to 4. Can you see that 2 is part of the set A? Okay, it's here, I've shaded. And 2 is also part of the set B because it's part of the line. Remember, B is from -3 to 4. So 2 is actually in both sets. So I'm going to use a closed bracket. And then 4 is part of the set B. At the same time, 4 is also part of A because A is from 2 to infinity. Okay, you can see that is part of there. So I'm also going to use a closed interval. So I'm going to close. So that's the answer for A intersection B. The way we do with sets is that you can write the right numbers, but if you use the wrong brackets, you get it wrong. Okay? Is that okay? Do we have any question from anyone? Any question? Okay. Yes, who has raised their hand? Bulaya. Yes, please. What determines that is that part shaded or is not shaded? If it is not shaded, then you use the open. If it is shaded, use the closed. In other words, are those two elements part of the set you are dealing with? If it's part, that means it's closed. Okay. Let's maybe do this other example. And I'm gonna write this as, let me include as intersection B so that you just get it properly. So we want to find A complement intersection B. They could have said also B minus A, it's the same. If you have a question like that, you start first with a complement. Okay, so start with the set A. Now the set A is from 2 to infinity. It's from here like this. That's the set A. If I want a set A complement, it's gonna actually start from 2. You've seen what I've done. The set A are the 2. So the set A complement will not have a 2. That's why I've put an open circle there. So in other words, if the set A was shaded, A complement will not be shaded. And because A is going in this direction, A complement will be going in this direction because we want what is outside. Okay, A complement is just what is outside. So that is the set A complement, this one. And to the left where we are going, what numbers are there? We are actually going towards negative infinity because we don't know where we're going to end. So that's a set A complement. And then I'm going to write a different set. I'm going to have the set A complement. Okay, I'm seeing some people are crying, meaning that they are confused. Don't worry, we're going to pull you together. We are forcing things. Okay, so that is a set A complement. And then remember, I want to find A complement intersection B. So the set B is from negative 3 up to 4. Negative 3 is not being included, but 4 is being included. That's the set B. So I want where A complement is intersecting with B. So it is from here up to here. This is the set. So therefore, A complement intersection B is negative 3 comma 2. Okay, it's from negative 3 up to 2. But you can see that at negative 3 it is open. So negative 3 is not part of the intersection because it's not part of one set. That's set B. So we'll use an open bracket. And 2 you can see is not part of A complement. So it can't be part of the intersection. We'll also open there. Now let me hear those that have got questions. Any questions? Yes, beauty. So the whole process will be first find a complement. Once you find a complement, also bring now the set B on the set A complement, and then find where they are meeting. That is a process of B. Okay, and I know you are not proper, so I've written a similar question, which I'm calling set C. Let's use it. Please follow it properly. Okay, question C. Follow it properly. We want to find A intersection B complement. It's similar to A complement intersection B. So for A intersection B complement, I'm going to first start with the. Please start with what is a complement. Starting with a B complement. So that is moving from negative 3 to 4, right? B itself is from negative 3 to 4. So we'll start with the set B. Okay. Negative 3 to 4. Remember, we are not including negative 3, but we are including 4. This is the set B, but I want a set B complement. Okay, so I'm going to go on 4. Can you see that 4 is shaded? So if I want the complement, I'll not shade on 4. And negative 3 is not shaded. If I want a complement, I'm going to shade on negative 3 because it wasn't shaded. In other words, negative 3 is not part of B, so it will be outside B. 4 is in B, so it can't be outside B. So because I want a complement, I'll write an arrow going in this direction and an arrow going in this direction, because that's where we have got the elements that are outside the set B. So what I've written there is B complement. I can bring it down now and put it like so. So negative 3, 4. So we have got like this and like that. This is the set B complement. But we want where the B complement is intersecting with A. So A is 2 to infinity. We want where to meet with B complement. So 2 is going to be somewhere here. And are we including 2? Yes. So it's going to start from here up to infinity. That is the set A. Now look at the set B, which is down, and the set B complement, which is down, and the set A, which is on top. Where are they meeting? Can you see that they are meeting from here all the way forward? And they are all having arrows going forward. That means that A intersection B complement is just from 4 all the way up to infinity. And 4, because it's not in the set B complement, it can't be part of the intersection. Therefore, that is going to be open. And because both of them are going towards infinity, infinity is always not included. So that is going to also be open. Is that okay, guys? Do we get it? So for me, I want to prove that you've gotten it if I give you another example. Because I'm not feeling well. Okay, let me give you. Okay, good. Example 2. So we are gonna have, let A be equal to negative 2 comma 1, and then B be equal to, let's say, 0 comma 4, and the universal set U be equal to negative 3 comma 5. Okay, let me make it interesting. I know and I'm in tension. Okay, negative 2 comma 4. Okay, this is it. And then find number A, we'll find A complement. B, we'll find A minus B. And then C, we'll find B minus A. Okay, let's do these ones. Let's start with the first. We want to find A complement. So the set A, please always first start with the A itself. The set A is from negative 2 to 1. Negative 2 is not being included. I know you might not be able to see what this screen is switching off sometimes. Okay. So negative 2 is not being included, but 1 is being included. So that's a set A. So the set A complement, therefore, is gonna start from on 1, because 1 is shaded, right? For A. For A complement, I will not shade. And then negative 2 is not shaded, meaning that negative 2 is not in A, so it will be outside A. Do we get it there? Do we understand? So negative 2 is not in A, so it will be outside A. In other words, at negative 2 you have an open circle. So in the set A, you have got an open circle at negative 2. So in the set A complement, you are going to have a closed circle at negative 2. You always swap them. If you have got an open circle for the complement, use a closed circle, and vice versa. Is that okay? Are we fine? Okay. Now this is a tricky thing. Please understand this, because we're supposed to draw a line, an arrow going in this direction, and an arrow going in this direction. You don't be used to arrows, guys. Okay, only use arrows when they've not specified the universal set, or if they've told you the universal set is a set of all real numbers. But for this question, the universal set has been restricted. We cannot go beyond negative 3 and positive 4. That's the universal set. So meaning to the positives, we can only go up to 4. That's why the universal set is ending. So I'm just going to reach at 4 and then shade, because remember 4 is part of the universal set. And then going to the negative side, we cannot go beyond negative 3. We only reach at negative 3. But remember, negative 3 is actually not part of the universal set. So I'll just reach at negative 3 and use an open circle there. What I'm saying is that the universal set is very, very important to take into account. If they have not specified the universal set, that's when you can use arrows for the complement of a set. But if they've specified the universal set, don't go beyond it. Are we alright? If the microphone is on, kindly switch it off. Okay. So therefore, the set A complement, yes, I've actually ended on 4. This one is a 4. Negative 3 comma 4. Okay, no, it's a 4. Alright. So the inverse, so therefore A complement is from negative 3 up to 2. You can see at negative 3 it's open. At negative 2 it is closed. And then we continue from 1 up to 4. At 1 it's open. At 4 it is closed. Okay, remember A complement has got this part and this part. For you to connect those two parts, you use a symbol union on the middle. That's how you write it. That's A complement. Now let's do the next one, which is A minus B. So for A minus B, remember A minus B is the same as A intersection B complement. So in other words, I need to know the set B complement first. So let's go on our number line. Our set B is from 0 up to 4. Okay. 0 is being included. 4 is not being included. Our set B complement, since 4 is not being included in B, so it will be outside B. So I'll put a dot there. Since 0 is included in B, it will not be outside B. So I'll put an open circle. Remember, I'll be going to the left. We'll only reach up to -3 because we can't go beyond the inverse set. And we are opening because -3 is not part of the inverse set. But for 4, can you see that that's actually where the inverse set is ending? Because the inverse set is ending at 4. I should have drawn at least a line to go to say we are going to reach where the inverse set is ending. But the inverse set is only ending at 4. That means that I only put a dot. That's all. Actually, let me put it like this. Let me change the set B, the question B, to say they asked to find B complement. Okay. So the set B complement is what I've written here. From 4 going forward, you don't have any elements forward because the inverse set is actually just ending at 4. So I'll just put a dot there. But from 0, we'll actually go all the way to -3 because we still have elements on the left. Therefore, the set B complement is going to be from -3 up to 0 union 4. But 4 is an element. It's not a range. Use curly bracket because it's an element. If you don't do that, you get it wrong. Okay? Yes, please. So at 0, because the set B, we shaded at 0. We can't shade for B complement. That's why I've not shaded. But at -3, the inverse set itself is not including -3. So that's why I've used an open circle there. Is that okay? Okay, good. The set C, we want to find now A minus B. Remember, for to find A minus B, this is the same as A intersection B complement. You first need to know the set B complement. And goodness, we've already found the set B complement. Okay? It is from -3 to 0 and then 4. So -3 to 0 and then 4. And then the set A, that is B complement. The set A is from -2 to 1. So -2 is actually somewhere here, and then 1 is here. What are we including for the set A? -2 we are not including, but we're including 1. So this is it, like this. That's a set A. So these sets are intersecting here. So therefore, A minus B is just from -2 to 0. And both of them will be open because -2 is not part of the set A. 0 is not part of the set B complement because it was also open. Is that okay, guys? Anyone that's left behind? Yes, please. So it's A intersection B complement. It's just the part that has the negative where you put a complement. Okay. So A minus B is A intersection B complement. That's okay? Ah, mhm. Okay. Understand it on DI. So D is B minus A. B minus A means B intersection A complement. So the second part is always the one that will carry a complement. Is that okay? And then for us to be able to find now the set, the first thing we need to find is A complement. But remember we already found A complement on top. It was negative 3 to negative 2 and then 1 to 4. Negative 3 to negative 2 and then 1 to 4. It was like this. That is the A complement. Let me just look at it again. Okay, that's true. And then B is 0 to 4. So 0 to 4. So 0 is going to be somewhere here. Okay, let me look at B again. We are not including 4, but we are including 0. So this will be shaded, but at 4 will not shade. That's a set B. So where this is intersecting is going to be like this. Okay. So therefore B minus A is just from 1 to 4. But 1 is not included, even 4 is not included because 1 is not part of A complement. 4 is also not part of B. So both of them can't be part of the intersection because intersection means they're appearing in all the sets. Let me even put one last question. A intersection, okay, not A intersection, but A union B complement. So for the union, again, we just get the set A. Yes, yes, they don't want the part for B. Maybe the problem is you're only looking at this set alone. I'm using the B complement because we already found it on top. So I've just gotten the set B complement already, which we found on top, and put it on a number line. We already found that this is B complement. And then we already found that this is the set A. And then you just see where B complement is meeting with A. The one you are talking about is if I wrote the set A on a number line, and then I wrote the set B on the number line. Okay, let's say if it was like this, 1 comma 2, like this. Okay, let's say this is a 4, and then let's say this is a 2, this is a 6. If this is A, this is B. If I say A minus B, I want what is in A, but not in B. So I just want this part here, only this part here. Okay, I don't want the part of A that is in B. This part, I don't want this part. So I don't even want this part of A. But this is not what I'm using. What I'm doing is that I first, because A minus B means A intersection B complement, I'm first finding B complement. And then I also find A, and then I put them on the same number line. So you can use any two methods, but please best first find B complement, and then you come and D, put it on one number line, and then also put the A, and then you work them together. I don't know if you get it. Do you understand that? Okay. All right, great. So let's find the last one, A union B complement. So I'm already getting B complement. B complement is from negative 3 to 0 and 4. Negative 3 to 0 and 4. It's like that. This is B complement. And then we want union A. They said A is from negative 2 to 1. Negative 2 to 1. Which one is not being included? Okay, one is being included. Okay, so let me use this color. Since we have got baby girls here, we use some pink. So that's A. Now, union means combining. Alright? So we want A union B complement. This means combining. So combine everything. So if you combine, you can see from negative 3, this line is going to join from here going straight all the way up to 1. That's combining. Union means combine. Intersection means look for what is common. So in other words, for A union B complement, we will start from negative 3 all the way up to 1. And 1 is included in the set A. And then union, you also have a comma 4. This comma 4 here, it will also be, remember it's union, but it's just an element alone. So you use a curly bracket. So union means combine. If they ask you to say also write the answer on a number line, this one on a number line is actually like this. Okay, when you combine negative 3 up to 1 like this, and then you have got 4. That's it. A union B complement. That is how you work out. I've got some good questions for you. We have got this one. We'll answer in the next class, but you try out and then share with me the solutions. This is the topic sets. We are done with the topic sets. Okay? Screenshot that. You try out. And then screenshot that. You try out. Screenshot that. You try out. Okay, I'm actually sharing just the document itself. Okay, so that you look at the questions and also the notes. Yeah, also that. Also that. Also that. Also that. Okay, even that. All right, guys, thank you very much.